In this video, we're going to look at specifically what factors affect the rate of enzyme activity. Okay, just to point out from last lesson, enzymes reduce activation energy by providing reactions with a better orientation. So this increases the frequency of successful collisions and therefore the reaction rate. Okay. So in this lesson, we're going to look at temperature, pH, and inhibitors that affect enzyme activity. Okay, so we'll start with temperature first of all. Okay, so enzymes have a narrow range of conditions under which they operate. Okay, so it's basically meaning that an organisms have optimum temperatures as well, but enzymes have certain ranges in which they can function in properly. So if we have, for example, a too cold temperature, okay, the enzyme is not actually functioning at its optimum, okay, its highest point. So the rate of reaction here, the rate of reaction is quite low when it's too cold. If we look up the top of the graph here, the optimum temperature of the enzyme itself is quite high. Okay, therefore we're going to have a higher rate of reaction when the temperature is warmer. If the temperature, however, gets too hot, okay, and is over its optimum range, then the enzyme is going to denature. Okay, denaturation just means that we're going to have some of the bonds break between those between the tertiary and quaternary structure that holds the enzyme together. Okay, that's going to then break, and then the substrate can no longer bind to the active site of the enzyme. Okay, so high temperatures are not good for enzymes because they can't function properly. So the lock and key model hypothesis states that the active site specifically matches the shape of the substrate molecule. Okay, so these few diagrams are going to demonstrate how the active site changes with denaturation with high temperatures, and then the substrate can no longer bind to the active site. Okay, here it can quite easily because the shape is the same. So at low temperatures, enzyme reactions go slowly because the molecules have low kinetic energy. Okay, they do still function, but just at a slower pace because they have less kinetic energy. Usually, molecules, and in this case, the substrates are going to be moving around more because they have more kinetic energy with higher temperatures. Okay, so only up to an optimum temperature, for example, 40 degrees Celsius. Okay, we can see there that the enzyme, the active site itself changes shape. So that means that this substrate can no longer bind to form the enzyme substrate complex.